Hello everyone, welcome back to Math 1314. This is Chapter 5, Section 1, Homework Assignments. Lesson number 1. Find the inverse of the relation. Remember, inverses, your first step is switch x and y. In other words, from xy, that's your function, to the inverse function, yx. So at this one, it would be 5, 3, negative 6, 6, comma, 9, 8, comma, negative 5, 5. Alright, so that's all you have to do to find the inverses. Switch the x and y's and just list it from there. It has to be inside the brackets, and it has to be in parentheses separated by commas. That's separated by commas. Find the inverse equation of the inverse function. So we have x equals y squared minus 6y. First step, switch x and y. That's going to be yx. And solve for y. We did. So there's your inverse. X squared minus 6x, which is b. Okay, let's look at number 3. Determine whether the following is one-to-one using the definitions of a one-to-one function. Okay, remember, if it's one-to-one, it has an inverse. So we have y equals 1/6 x minus 4. First thing you do, switch x and y. Now solve for y. Add 4 first. So we have x plus 4 equals 1/6y. Get rid of the 1/6, multiply both sides by 6. 6x, 6 times 4 is 24. The 6's cancel, so that's your inverse. Since it does exist, then it's yes. It is one-to-one. Now, we could also tell it's one-to-one because it's linear. In order to be one-to-one, it has to pass the horizontal line test. Linear equation, the graph only crosses once. Number 4. Use the horizontal line test to determine if the function is one-to-one. No, because it fails all these horizontal lines. Is it one-to-one? No. Alright. Next page. Question 5. Use the horizontal line test to determine if the function is one-to-one. Yeah, any horizontal line we use, it only touches it once. Is it one-to-one? Yes. Which means it does have an inverse. The graph of the function and determine whether the function is one-to-one using the horizontal line test. Okay, let's rewrite this equation. So decreasing, so it's negative x squared minus 2. We see it's quadratic, so we know the graph is going to be like this or like this. It's negative, so it points down. There's no horizontal shift, it's just a vertical shift. So it points down and it goes down 2 spaces. So remember, the original graph starts at the origin and goes up. But since it's negative, it flips down. And since it's a vertical shift, it goes down to -2. And it graphs it from there. Plot some points. We'd create a table. So -2, -1, 0, 1, 2. At 0, it's -2. Remember, if it's, let's see, y-intercept is a constant. X is -1. -1 squared is 1, so it's -1. -2 is -3. Which is there. Because it's symmetric, it's also going to be -3 on the one side. 1 on both sides, it goes down 1. -2. -2 squared is 4. So it's -4 minus 2 is -6. Same there, so which is there. That's the graph. Is it 1-to-1? No. Because at least one horizontal line intersects the graph. This one can't be right. No, because no horizontal line intersects it. No, that's just the opposite. If a horizontal line crosses it more than once, then it's not 1-to-1. Number 7. Determine whether the function f of x is 1-to-1. If it is 1-to-1, find a formula for the inverse. Again, it's self-serving because we have to first change the function, change it to y, switch x and y, now solve for y. So we have to get out of this radical. Since it's √3, we have to take both sides and cube it. The root and the cube disappear. And so we have 9y equals x cubed. Divide by 9. So we have our function. So 1/9 x cubed. So x cubed over 9 is 1/9 x cubed. Just remember, since there's no horizontal shifts, nothing else, the cubic function looks like this. It's just 1/9, so it's a lot shorter. So is 1-to-1? Yes. The inverse function is 1/9 x cubed. And the last one. Find the equation of the inverse function of the following relation. So first off, we have to switch x and y. Now solve for y. Add 2 to both sides. We got x, let me put it over here. Y equals 5x minus 2. First switch x and y. Now solve for y. Add 2 to both sides. Equals 5y. Divide by 5 each term. So we have the inverse, since y is by itself, that's the inverse. 1/5x plus 2/5. And there's your relation. 1/5x plus 2/5. Okay, remember, I just like the way this looks. This is the same thing as x/5. So it doesn't matter how you write it, it's going to give you the same answer. Alright, good luck everybody.